In the last few years, the scientists have made some really incredible discoveries about our own galaxy, the Milky Way. Discoveries that really redefined our understanding of what our galaxy looks like. And so even though we kind of assume that the galaxy might resemble something like this, the reality is a lot more complicated. First of all, it seems to be kind of warped. It also has all of these unusual streams around it. It has a very large halo that's also slanted as well, and possesses a lot of other features such as globular clusters present all over the place. With all of this discussed in some of the previous videos you can find in the description. But more unusual features become apparent if you start observing the galaxy in other frequencies. For example, radio frequencies, infrared light, or even X-ray and gamma ray light that obviously our eyes cannot see, which obviously transforms the galaxy even more. So here's the visible light, here are some of the older observations in the X-rays, the gamma rays, the infrared light, microwave light, and of course radio light as well. But these observations are on a slightly older side. A lot of newer observations started to discover some really incredible features that even today we have trouble explaining. And today we're going to be discussing one of these features, unusual string-like formations, or unusual filaments that seem to be present in the Milky Way itself, but also seem to be present outside of the galaxy, and obviously in other galaxies as seen by various other telescopes. And here we're talking about these very strange filaments we discussed in one of the previous videos, once again in the description below, that kind of become apparent if you look at the galaxy by observing it in radio frequencies. Filaments that stretch for at least several light years, and that seem to propagate throughout the galaxy and seem to be located in a lot of different regions. Although predominantly they seem to be associated with a lot of ancient supernova, or regions with a lot of molecular gas that might possess quite a lot of magnetic energy, which the scientists believe creates these unusual phenomena. And so in some sense these are believed to be magnetic filaments, potentially related to a much smaller phenomenon of solar filaments we observe on the surface of the Sun that is magnetic in nature, but also obviously may be formed in some entirely different way we still don't understand. And intriguingly, the scientists behind this recent paper have actually originally discovered the first filament back in the 1980s, pretty much 4 decades ago. Only a small one was seen at first, but more and more started to be discovered as our telescopes became better. And today, over 1,000 filaments have already been discovered all across the Milky Way galaxy, with some of them stretching all the way up to 150 light years in length, with some of the longest ones being located very close to the center of the galaxy. But the recent paper focused on something slightly different, discovering similar filaments in other galaxies, such as this distant radio galaxy that has somewhat similar filaments formed by the massive black hole in the middle, with several other similar filaments discovered in some other galaxies, but intriguingly all of them being dramatically longer than anything in the Milky Way. For example, this one right here is over 300 light years in length, several times longer than a typical filament in the Milky Way galaxy. And although many of them do seem to resemble the ones we've discovered in the Milky Way as well, such as the one on the right, in terms of the sheer size, they're just dramatically larger. As you can see, the one on the left is approximately 3,000 times longer, even though it possesses a relatively similar shape. Here is another comparable image between the Milky Way on the bottom, an object referred to as feather, and another object 25,000 times larger, located in a distant galaxy, but with somewhat similar features. But in most cases, a lot of these observations came from very active, very massive radio galaxies with really powerful black holes in the center. Although because of the similarity in structure, it might actually appear as if it was created by a relatively similar type of phenomenon, and so the underlying physical mechanism could be generally the same. But unlike the filaments in the Milky Way galaxy, are only visible because, first of all, they're much larger, but they also seem to be much older, very likely existed for millions or even billions of years. Although a lot of newly discovered filaments mostly seem to be part of a large galactic cluster that contains thousands of different galaxies interacting with one another approximately 1 billion light years away from planet Earth. But it's the radio galaxies within the cluster that seem to be forming a lot of these filaments. Although despite being very likely more powerful and much larger, their overall magnetic field is much weaker as well, at least 1,000 times weaker than what we actually observe here in the Milky Way. And also, unlike the variety of filaments in the Milky Way galaxy, the majority of extragalactic filaments seem to be mostly at 90-degree angle from the black hole jets that usually look something like this, which means that they create a kind of unusual shape that's I think better visible right here. And this particular feature is obviously kind of difficult to explain right now. But because the overall shape is very similar to what we see in the Milky Way, and because even the length to width ratio is exactly the same, the overall mechanism responsible for their production is believed to be the same as well, or at least extremely similar. For example, as seen in this filament, it seems to possess more energy closer to its origin, and in this case it's closer to the jet from the black hole, but starts to lose energy as it travels farther down, eventually disappearing into nothingness. And in both cases, it's not entirely clear where all of this originates. For example, for the radio galaxy, it's assumed that the jet provides the initial energy, with the filament then moving on its own path and losing the energy in the process. But what exactly makes these filaments so long and allows them to accelerate for such a long distance is still not entirely clear. I mean, for example, here you're looking at something that's over 150,000 light years in length. That's basically the size of our own galaxy. More intriguingly, this seems to be formed by electrons traveling along the magnetic lines, and because they don't travel at the speed of light, it means that for some of these objects, these electrons travel for 100 or even 500,000 years before they finally disappear. In some cases, this can be up to 1,000,000 years, and what exactly allows them to travel for so long without breaking apart is of course unknown. Now, one potential explanation here is, well, maybe all of this comes from the motion of the galaxy itself. As the galaxy rotates, it might create a comet-like tail behind it, essentially forming these unusual filaments. The interaction between the motion of the galactic edge and the stuff between galaxies maybe creates some of these filaments in the process. Or the other explanation could be related to some kind of a turbulence inside a relatively weak magnetic field. As various galaxies inside the cluster move around, the resulting interaction can start creating various vortices and a lot of motion on the inside. And as the weak magnetic field starts to wrap around these disturbances, it can get stretched, folded, and amplified, with time resulting in the variety of different filament-like structures with relatively strong magnetic field inside of them. At least that's one of the two explanations the scientists propose right now, although the reality is that we still actually have no idea how many of these are formed. And more realistically, we actually have no idea if the ones inside the Milky Way, despite their similarity, have anything in common with the ones outside of the Milky Way, or if these are actually completely different phenomena despite their similarity in shape. Now, it's most likely that these are magnetic in nature, and very likely are the result of something extremely powerful, such as a supernova producing these over time, but there's also a chance that many of these are created by different events that actually result in similar observations. And so in other words, even after years and years of research, we found so many, over 1,000 now, yet the actual origin is still a little bit mysterious. But more importantly, by identifying more of these extragalactic magnetic filaments, it might actually become possible to start answering these questions by comparing their origins. Because modern radio telescopes have become so much more powerful, it's quite likely we'll be discovering so many more in the years to come. And eventually, hopefully, the scientists figure out the source of all of these filaments, which then will hopefully lead to some major breakthroughs in understanding the galactic evolution, but also possibly discovery of some really unusual effect we didn't know existed. But until these future discoveries, well, for now at least, that's all we have. Just another new discovery of something really long, really large, and something really mysterious that we don't really understand. Extragalactic filaments we've never seen before. Until future discoveries, thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, and maybe support this channel on Patreon by joining channel membership or by buying the wonderful person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.